Hi everybody and welcome back to Absolution Water. My name is Julio Reyes and let's do another math problem. The question reads like this. A water storage reservoir is 40 feet when it is full. What is the level in the reservoir when the current milliamp reading is 7? So this falls into a 4 to 20 milliamp span question. And how do we recognize that? Really, two factors tell me that. There's only two here. We are given what the range is when, in this case, it could be anything, but in this case, it is when the reservoir level is full. It's reading 40 feet. And then the next indicator is that we're also given what the current electrical milliamp reading. It's 7. So these, unlike others, this type of question is a little more straightforward. We're given two indicators, and we know that this is going to be that 4 to 20 milliamp span. So let's go ahead and write down the formula for this question. It's going to be the entire range, which I'm just going to call ER, over 16 milliamps. Where do those 16 milliamps come from is, I'm going to write down on the bottom here, 4 is going to be when your range is 0 level, and 20 milliamps is in this case when your range is 40 feet. So the difference between this 4 and that 20 is 16. So you might just ask, why, whoever kind of came up with this idea, why don't they just use 0 milliamps as 0 feet? And the answer is, well, what happens if you have a power outage? Your milliamps will go to 0, and you won't know that you have a power outage. You'll just have the tank is at 0 feet. And so some smart guy just decided to come up with the 4 milliamps. Okay, and the rest of the formula is multiplied by your live signal, which I'm just going to call live, minus 4, which is your offset. And let's keep our units of measure, milliamps, all over, clean up this V, 1. So right below it, here's how the way I like to memorize formulas and the way I like to teach people to memorize formulas is rather than, as soon as you recognize a type of formula that you need to use, I always write down the general formula first. And then I rewrite the formula with its numbers. So in essence, you have kind of acquainted your brain with the formula twice. And it provides a good template too. So let's plug in what we know. So we know that the entire range, I'm going to write it right below the template there, is 40 feet. And it's going to be over 16 milliamps. Units of measure are going to be very important. If you're not familiar with converting and units of measure, then see my first video. And this is going to simplify to that 40 divided by 16 is going to be 2.5. And we're left with feet over milliamps. Okay? Believe it or not, we're already halfway there. And then our live signal on the top is 7. So the difference between 7 and 4, here's 7, and there's our 4. The difference between 7 and 4 is 3. Let's keep our units of measure, milliamps, over 1. Now, notice milliamps are going to cancel with milliamps, and we're left with, if we divide 40, if we multiply 2.5 times 3, we're left with 7.5. And the only unit of measure that we're left with are feet. And so therefore, they will carry over. So the answer is 7.5 feet. I hope you found this helpful. For more videos like this and other resources, visit our website at www.absolutionwater.com.